Okay, for this one, we are going to graph a quadratic using the steps that we did in that first video. In this one, it's just in vertex form. Now, vertex form is the best way to get this started and to look at, because vertex form is just commonly, well, I guess maybe not commonly, but also known as transformation form, because you can look at all of these values and figure out what the transformations are. This a value, if a is negative, what do you know if there's a negative all the way in front? Vertical reflection. Good. See, we're using that transformation and putting it in here. So if I have a vertical reflection of a quadratic graph or a parabola graph, what's that going to happen? Yep, it's going, so my normal graph goes up. When I put a negative reflection on it, it's going to look like a hill instead of a U. Good, okay. A also has more than one role. We know it can be positive or negative, and the number also plays a role. So you know if A is between 0 and 1, that's going to be a vertical shrink. And if A is greater than 1, that's going to be a vertical stretch. Awesome. So we have lots of stuff going on there. Now, remember what we said. If I have a number that is inside the parentheses or inside my function, and in this instance, it's going to be my h. What does h represent here? Horizontal, yes, horizontal shifting. Notice that minus sign. What did we say whenever we said anything numeric of transformations? How does that work? So any horizontal numeric transformation, reflecting is what I'm trying to get at. Reflecting doesn't really matter. But if you have horizontal stretch and shrink or horizontal shifting, then what do you know about that? It's always opposite. Anything horizontal is opposite. Right on. So notice this minus sign. That's where the opposite comes in, because all of your formulas have that. Pretty sweet, huh? So you know that that is opposite. And in the back is going to be my vertical shifting, and that's going to be the same. So opposite horizontal and the same vertical. Okay, so whenever I'm looking at those numbers, what that actually is ending up telling me is that wow, what a crazy sentence, is the H and the K represents my vertex. And guess what? We know mathematicians aren't creative, right? And they're not. This is called vertex form. So guess what, people? You're going to get your vertex out of this deal. Vertex form. You got this. So we get our vertex, and our vertex, people, is the star of the show. I don't know that I have any little fancy pants things on here I can put in here to make this look awesome, but let's try something like this. Nope, I was going to do something better, but it didn't show up that way. So, okay. All right, so let's try one on for size here. Remember, the vertex is the star of your show, so the first thing you want to look at is your vertex. There's some other information we're also going to pull out of this problem, but we're going to start with the vertex. Okay, I just put everything down there so we have it now, but let's look at the vertex first. Remember, the vertex is our inside function is always opposite in the inside of the function, and then it's the same. So our vertex for this problem ends up being what? Positive 2, 1. Good, so 2, 1. Remember, your vertex is your point. So that is the point that we're looking at. Now, just because it is awesome information, look at this problem. Is this problem going to be a U, like a parabola, or is it going to be a hill? Yes, it's going to be a hill. Tell me why. Yep, I know that this, with that negative sign in my A value, it's going to reflect over the x-axis. And when it reflects over the x-axis, then it becomes that hill. Good. How does that 3 work? We used the 2 and the 1 already. What's up with that 3? Vertical stretch, rock on. So you know it goes down, and it's a vertical stretch, so it's going to be narrow. So it's going to go down and be narrow. Awesome. Well, let's do it right now. So remember, I told you can either use the t-chart or the XY new Y chart. Now the examples that I'm going to do, I'm going to use the XY new Y chart for these because it is quicker, and in my opinion, it is easier. Now, something else that I want to let you know, oops, I spelled that terribly. Something else that I want to let you know is I took off all of the helping tools for this assignment because they are crazy whenever they went to solve these problems and to look through this stuff. So how I'm showing you is how you need to do it. So if you need helping tools, come back to these videos. The Help Me Solve This is not on there because it'll just make it worse. It always makes it worse every semester. Okay, so remember on that green chart, we automatically put in plus or minus 1 and 2 because that was our pattern. And if I square the 1, that's going to give me a 1. If I square the 2, that gives me a 4 because you know this is a quadratic and it's squared. So then that is our movement. So instead of making a T-chart and figuring out the vertex and going up 1 and then up 2, I'm taking care of that right here. Now your XY new Y chart is movement from the vertex. This is always how you move from the vertex. Always. So this is just going to give me movement. Instead of having to do specific points, it lays it out for me, which is really pretty cool. Awesome. Okay, so let's do it right now. If I have -3, -3 in this instance is going to be my A value. So I'm going to put -3 in that slot. And then we're going to multiply. Because when you multiply to get, or when you have a vertical stretch, you multiply to get your vertical stretch, right? So I'm going to multiply, and that's how I get a new Y, because I have to take into account my vertical stretch and the reflection. We're just doing it all at once. Those are technically 2 different steps, but I don't see any point in making them 2 steps. Just take care of it at once. So let's do it right now. I have 1 times -3, and that is going to equal a -3. Then I have 4 times -3, and that is going to equal a -12. Now, when you graph these on your paper, I want you to go ahead and graph them. But when you graph it in my math lab, all you have to have is 2 points. So if one of these works better for your grid than another, such as I'm anticipating this -12 to be off my graph, then you don't have to plot all of those points. Okay, but we're graphing it, so let's do this thing. You start with your vertex because it's the star of your show. Everything goes off of your vertex. So there's my vertex at the point 2, 1. Then my movement is I'm going to go plus or minus 1, and then my new Y is down 3. So when you graph using your XY new Y chart, you are going to graph your X and your new Y. So from my vertex, I'm going to go +1, down 3, and make a point, and I'm going to go -1 and down 3 to make my point. Notice I didn't have to plug anything in. I didn't have to do a T-chart. I put the blue on there because the blue is to show movement, but I'm going to take that off right now because I don't want you to think that's actually part of your graph. That's just how you get to your next point. Cool. So now I have 2 plus or minus 2 and -12. So back to the vertex. That's the important thing. You always, always, always go back to that vertex. Whatever it is that you want to try to find or that you're looking at is always back to the vertex. So if I go back to the vertex, then I'm going to move over 2 and down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to be just off of my graph by 1. So that's not too bad. Then I go +2, back from the vertex, I'm going to go over 2 and then again down 12. So you're going to see that this is symmetric, and wherever you are on one side, you're going to be on the other, and that also helps with graphing points. So now I have this nice narrow parabola. Notice, what did we predict was going to happen? That it was going to be a hill, and is it? Yes, it is. Now, look at these other things that I have going for us. We have the axis of symmetry. An axis of symmetry is simply the line down the middle. So in this instance, our axis of symmetry goes right down the vertex. Not just in this instance, always with a quadratic, it's going to go right down the vertex, because if you were to fold up that vertex, like fold up your parabola around the vertex, it's going to land on itself, right? And that's what makes it the axis of symmetry, down the middle, that is symmetric from there. So a line, that's a vertical line. So an equation of a vertical line is x equals some number, and in this instance, x equals 2. Now, does the 2 look familiar from anything else? Right you are. Da-da-da-da-da-da. It is also the vertex. The vertex, the x value of your vertex is the axis of symmetry. That's where that goes. Cool. Now, what about the domain for this quadratic? All real numbers. How do you know it's all real numbers? Yep, look at those arrows. Now, this is a super skinny graph, but those arrows still are going to go to the left and to the right infinitely. So my domain is going to go from negative infinity to positive infinity. Good, but what about the range? Yeah, because of the hump, it's not infinity, but it goes down forever infinity, right? But then it comes up here and stops. So where does it stop at? Positive 1. So I'm going from negative infinity to positive 1. Now, does that 1 have a parenthesis or a bracket on it? Bracket, good. Why? Because it's included in my graph, right? Good for you. Okay, you guys are awesome. If we're looking at this, where else have you seen that 1? Yes, indeedy. Back to the vertex. I told you it was the star of the show, and this is. You can always, your vertex tells you your axis of symmetry. Your vertex tells you your range. Your vertex is what you graph from. I mean, you need to know your vertex. It is the star of the show. That's why we have a vertex form. So we can graph from that, and it makes it so much easier. Awesome. You guys are doing great.